wireless technologies, what comes to your mind? I guess you are thinking about internet communication, Bluetooth communication, etc. And well, that's right. Wireless communication is the transfer of information or power between two or more points that are not connected by an electrical conductor. The most common wireless technologies use radio. With radio waves, distances can be short, such as a few meters for television or as far as thousands or even millions of kilometers for deep space radio communications. It encompasses various types of fixed, mobile, and portable applications including two-way radios, cellular telephones, personal digital assistants, and wireless networking. Other examples of applications of radio wireless technology includes GPS units, garage door openers, wireless computer mice, keyboards and headsets, headphones, radio receivers, satellite television, broadcast television, and cordless telephones. Somewhat less common methods of achieving wireless communications include the use of other electromagnetic wireless technologies such as light, magnetic, or electric fields, or the use of sound. The term wireless has been used twice in communications history, with slightly different meaning. It was initially used from about 1890 for the first radio transmitting and receiving technology, as in wireless telegraphy, until the new word radio replaced it around 1920. The term was revived in the 1980s and 1990s mainly to distinguish digital devices that communicate without wires. This is its primary usage today. So these are the subtopics of this chapter: wireless LAN, PANs and Bluetooth, Zigbee and mesh wireless networks, WiMAX and metropolitan area networks, infrared wireless, radio frequency identification and near field communications, and last is the ultra wideband wireless. Let's talk about first the wireless LAN or wireless local area network. A wireless local area network is a wireless computer network that links two or more devices using a wireless distribution method within a limited area such as home, school, computer laboratories, or office building. This gives users the ability to move around within a local coverage area and still be connected to the network, and can provide a connection to the wider internet. A wireless distribution system enables the wireless interconnection of access points in an IEEE 802.11 network. It allows a wireless network to be expanded using multiple access points without the need for a wired backbone to link them, as is traditionally required. The notable advantage of WDS over other solutions is that it preserves the MAC addresses of client packets across link between access points. An access points can be either a main, relay, or remote base station. A main base station is typically connected to the wired Ethernet. A relay base station relays data between remote base stations, wireless clients, or other relay stations to either a main or another relay base station. A remote base station accepts connection from wireless clients and passes them to relay or main stations. Connections between clients are made using MAC addresses rather than by specifying IP assignments. All base stations in a wireless distribution system must be configured to use the same radio channel and share WEP keys or WPA keys if they are used. They can be configured or different services set identifiers. When it is difficult to connect all of the access points in a network by wires, it is also possible to put up access points as repeaters. Wireless LANs have great deal of applications. Modern implementation of WLANs range from small in-home networks to large campus-sized ones to completely mobile networks on airplanes and trains. Users can access the internet from WLAN hotspots in restaurants, hotels, and now with portable devices that connects the 3G or 4G networks. Oftentimes, these types of public access points require no registration or password to join the network. Others can be accessed once registrations has occurred and or a fee is paid. Existing wireless LAN infrastructures can also be used to work as indoor positioning system with no modification to existing hardware. The 802.11 family consists of a series of half-duplex over-the-air modulation techniques that use the same basic protocol. 802.11 of 1997 was the first wireless networking standard in the family, but 802.11b was the first widely accepted one, followed by 802.11a, 802.11g, 802.11n, and 802.11ac. Other standards in the family, C2F and HJ, are service amendments that are used to extend the current scope of the existing standard. 802.11 technology has its origin in a 1985 ruling by the U.S. Federal Communications Commission that released the ISM band for unlicensed use. In 1991, NCR Corporation invented a precursor to 802.11 in Nieuwegein, the Netherlands. The inventors initially intended to use the technology for cashier system. The first wireless products were brought to the market under the name WaveLAN with raw data rates of 1 Mbits and 2 Mbits. Vic Hayes, who held the chair of IEEE 802.11 for 10 years and has been called the father of Wi-Fi, was involved in designing the initial 802.11b and 802.11a standards within the IEEE. The earliest useful and most widely adopted version of the 802.11 standard is 802.11b. The 802.11b standard has a maximum raw data rate of 11 Mbits and uses the same media access method defined in the original standard. 802.11b products appeared on the market in early 2000. Since 802.11b is a direct extension of the modulation technique defined in the original standard. The dramatic increase in throughput of 802.11b, along with simultaneous substantial price reductions, led to the rapid acceptance of 802.11b as the definitive wireless LAN technology. Devices using 802.11b experience interference from other products operating in the 2.4 GHz band. Devices operating in the 2.4 GHz range include microwave ovens, Bluetooth devices, baby monitors, cordless telephones, and some amateur radio equipment. The newest standard is the 802.11n version. 802.11 uses multiple input or multiple output technology and a wider radio frequency channel. It also provides a mechanism called frame aggregation to decrease time between transmissions. Current wireless LAN technologies require that the sending station request the channel, send one packet, release the channel, and then request again in order to send the next packet. With frame aggregation, once a station requests the channel and has the authority to transmit, it can transmit a series of frames without having to release the channel and regain authority for each time. With 802.11n, raw data throughput is expected to reach as much as 600 Mbps. That that's more than 10 times the throughput of 802.11g. Wi-Fi uses radio waves to allow two devices to communicate with one another. The technology is most commonly used to connect internet routers to devices like computers, tablets, and phones. However, it can be used to connect together any two hardware components. Wi-Fi is a local wireless network that runs off the 802.11 standards set forth by the Institute of Electrical and Electronics Engineers, or IEEE. Two stronger encryption standards called Wi-Fi Protected Access, or WPA, and WPA2 are also available in several forms to further boost the encryption process. The IEEE also has security standard called 802.11i that provides the ultimate in protection. IEEE 802.11i of 2004, or 802.11i for short, is an amendment to the original IEEE 802.11, implemented as Wi-Fi Protected Access 2. The draft standard was ratified on 24th of June 2004. This standard specifies security mechanism for wireless networks, replacing the short authentication and privacy clause of the original standard with a detailed security clause. A personal area network is a very small network that is created informally or on an ad hoc basis. A personal area network is a computer network used for data transmission amongst devices such as computers, telephones, tablets, and personal digital assistants. PANs can be used for communication amongst the personal devices themselves, or for encoding to a higher level network and the Internet, where one master device takes up the role as Internet router. A PAN typically involves two or three nodes, but some systems permit many nodes to be connected in a small area. The most popular wireless PAN system is Bluetooth, a standard developed by the cell phone company Ericsson for use as a cable replacement. Bluetooth uses short-range radio waves over distances up to approximately 10 meters. For example, Bluetooth devices such as a keyboard, pointing devices, audio headsets, printers may connect to personal digital assistants, cell phones, or computer wirelessly. A Bluetooth PAN is also called a piconet, combination of the prefix pico meaning very small or 1 trillionth network, and is composed of up to 8 active devices in a master-slave relationship. The first Bluetooth device in the piconet is the master, and all other devices are slaves that communicate with the master. A piconet typically has a range of 10 meters or 33 feet, although ranges of up to 100 meters or 330 feet can be reached under ideal circumstances. Bluetooth devices can also link to other piconets to establish larger scatternets. A scatternet is a number of interconnected piconets that supports communication between more than 8 devices. Scatternets can be formed when a member of one piconet elects to participate to a slave in a second, separate piconet. The device participating in both piconets can relay data between members of both ad hoc networks. However, the basic Bluetooth protocol does not support this relaying. In this figure, you can see that up to 7 devices can be actively connected in the piconet. But with the use of Scatternet Link, it can support more than 8 devices. ZigBee is the commercial name for another PAN network technology based on the IEEE 802.15.4 wireless standard. ZigBee is an open global standard and is designed specifically to be used in M2M networks. The technology is inexpensive to run and doesn't require a lot of power, making it an ideal solution for many industrial applications. ZigBee's virtue is its versatile networking capability. The standard supports these topologies star, mesh, and cluster tree. The most commonly used are the star and the mesh. The star topology consists of a coordinator and several end devices or nodes. In this topology, the end devices communicates only with coordinator. Any packets exchanged between end devices must go through the coordinator. The disadvantage of this topology is the operation of the network depends on in the coordinator of the network. And because all packets between devices must go through coordinator, the coordinator may become bottleneck. Also, there is no alternative path from the source to the destination. The advantage of star topology is that it is simple and packets go through at most two hops to reach their destinations. Mesh topology, also referred to as a peer-to-peer network, consists of one coordinator, several routers, and end devices. The following are the characteristics of mesh topology. A mesh topology is a multi-hop network. Packets pass through multiple hops to reach their destination. The range of a network can be increased by adding more devices to the network. It can eliminate dead zones. A mesh topology is self-healing, meaning during transmission, fails, the node will find an alternate path to the destination. Devices can be close to each other so that they use less power. Adding or removing a device is easy. Any source device can communicate with any destination device in the network. Compared with star topology, mesh topology requires greater overhead. Mesh routing uses a more complex routing protocol than a star topology. These network topologies are made up of three types of ZigBee nodes: ZigBee coordinator, ZigBee router, and ZigBee end device. ZigBee coordinator is the most capable device. The coordinator forms the root of the network tree and might bridge to other networks. There is precisely one ZigBee coordinator in each network, since it is the device that started the network originally. It stores information about the network, including acting as the trust center and repository for security keys. ZigBee router. As well as running an application function, a router can act as an intermediate router, passing on data from other devices. ZigBee end device contains just enough functionality to talk to the parent node. It cannot relay data from other devices. This relationship allows the node to be asleep a significant amount of the time, thereby giving long battery life. A ZigBee end device requires the least amount of memory and therefore can be less expensive to manufacture than a ZigBee router or ZigBee coordinator. These are the figure of star and mesh topologies. ZigBee can address a wide range of wireless needs. It was designed primarily for monitoring and control. Monitoring refers to looking at a wide range of physical conditions, especially temperature, humidity, pressure, the presence of light, speed, and position information. Control refers to the sending of command signals to initiate some action. Typically, commands are used to turn things off and on, such as lights, motors, solenoids, relays, and other devices. WiMAX, or Worldwide Interoperability for Microwave Access, is a family of wireless communication standards initially designed to provide 30 with a 2011 update providing up to 1 gigabytes for fixed station. The name WiMAX was created by the WiMAX Forum, which was formed in June 2001 to promote conformity and interoperability of the standard. The forum describes WiMAX as a standards-based technology enabling the delivery of last-mile wireless broadband access as an alternate to cable and DSL. IEEE 802.16m, or Wireless MAN Advanced, is a candidate for the 4G in competition with the LTE Advanced standard. A metropolitan area network is a network that interconnects users with computer resources in a geographic area or region larger than that covered by even a larger local area network, but smaller than the area covered by a wide area network. The term is applied to the interconnection of networks in a city into a single larger network. It is also used to mean the interconnection of several local area networks by bridging them with backbone lines. The later usage is also sometimes referred to as campus network. Examples of metropolitan area networks of various sizes can be found in the metropolitan areas of London, England, Lodz, Poland, and Geneva, Switzerland.
Infrared wireless is the use of wireless technology in devices or systems that convey data through infrared radiation. Infrared is the electromagnetic energy and the wavelength somewhat longer than those of red light. The shortest wavelength infrared border visible red in the electromagnetic radiation spectrum. The longest wavelength infrared borders radio wave. Infrared wireless is used for short and medium range communication and control. Some systems operate in line of sight mode. This means that there must be a visually unobstructed straight line through space between the transmitter and the receiver. Other systems operate in diffuse mode, also called scatter mode. This type of system can function when the source and destination are not directly visible to each other. An example is a television remote control box. The box does not have to be pointed directly at the set, although the box must be at the same room as the set or just outside the room with the door open. Unlike radio frequency wireless links, infrared wireless cannot pass through walls. Therefore, infrared communication or control is generally not possible between different rooms in a house or between different houses in a neighborhood. This might seem like disadvantage, but infrared wireless is more private than radio frequency wireless. Some infrared wireless seems offer a level of security comparable to that of hardwired system. One example of infrared wireless is TV remote control. All remote control devices work on the same principle. A small handheld battery-powered unit transmits a serial digital code via an IR beam to a receiver that decodes it and carries out the specific action defined by the code. The remote control is one of the more sophisticated of this control, for it requires many codes to perform volume control, channel selection, and other functions. The encoder circuit converts this input to a unique binary code representing a number to channel selection or some function such as volume control. A standard non-return to zero serial code is generated and applied to a serial encoder. In telecommunication, a non-return to zero line code is a binary code, in which ones are represented by one significant condition, usually a positive voltage, while zeros are represented by some other significant condition, usually a negative voltage, with no other neutral or rest condition. The pulse in a return zero have more energy than a return to zero code, which also has an additional rest state beside the conditions for ones and zeros. Infrared personal area network. Beside remote control, the primary application for infrared data communication is in short distance links between computers, and printers. There must be a clear line of sight between the transmitter and the receiver. The signal is amplified and shaped and then sent to the decoder, which recovers the original data. A better arrangement is a transceiver dongle, which consists of capable attachment to the interface in the PC or PDA and to the movable dongle containing the LED and PIN diode. The term dongle is also associated with the similar devices meant to provide additional forms of wireless connectivity to devices, often over USB connections, as well as the small forms of factor, digital media players, and personal computers, meant to plug directly into an HDMI input. Also, a dongle is a small piece of hardware that connects to another device to provide it with an additional functionality. In relation to computing, the term is primarily associated with hardware providing a copy protection mechanism for commercial software, in which the dongle must be attached to the system that the software is installed in order for it to function. Infrared Data Association is an industry standard for wireless communication with infrared lights. Many laptops sold today are equipped with an infrared data association compatible transceiver that enables communication with other devices, such as printers, modems, LANs, and other laptops. The transfer speed ranges from 2400 bps to 4 Mbps. Infrared Data Association have two operation modes, the standard mode and the faster mode. Standard mode accesses the infrared port through a serial interface. This mode works on almost all systems and is sufficient for most requirements. The faster mode requires a special driver for the infrared data association chip. Not all chip types are supported in faster mode. Because of a lack of appropriate drivers, set the desired infrared data association mode in the BIOS of your computer. The BIOS also shows which serial interface is used in the standard mode. Radio frequency identification is a technology that incorporates the use of electromagnetic or electrostatic coupling in the radio frequency portion of the electromagnetic spectrum to uniquely identify an object, animal, or person. Radio frequency identification is coming into increasing use in industry as an alternative to the barcode. The advantage of radio frequency identification is that it does not require direct contact or line of sight scanning. Also, radio frequency identification system consists of three components: an antenna, transceivers, and transponder. The antenna uses radio frequency wave to transmit a signal that activates the transponder. When activated, the tag transmits the data back to the antenna. The data is used to notify the programmable logic controller that an action should occur. The action could be as simple as raising an access gate or as complicated as interfacing with a database to carry out a monetary transaction. Low frequency of radio frequency identification system have short transmission ranges. High frequency radio frequency identification system offer longer transmission ranges. In general, the higher the frequency, the more expensive the system. Near-field communication is a set of short-range wireless technology, typically requiring a distance of 4 cm or less to initiate a connection. Near-field communication allows you to share small payloads or data between a near-field communication tag and an Android-powered device, or between two Android-powered devices. Ultra-wideband wireless can use a very low energy level for a short range, high bandwidth communication over a large portion of a radio spectrum. Ultra-wideband has traditional application in a non-cooperative radar imaging. Most recent application targets sensor data collection, precision locating and tracking application. Unlike spread spectrum, ultra-wideband transmit in a manner that does not interfere with conventional narrowband and carrier wave transmission in the same frequency band. Also, ultra-wideband is a technology for transmitting information spread over a large bandwidth. This should, in theory and under the right circumstances, be able to share spectrum with other users. Regulatory settings by the Federal Communication Commission in the United States intend to provide an efficient use of ratio bandwidth while enabling high data rate personal area network wireless connectivity, long range, low data rate application, and radar and imaging system. Pulse ultra-wideband hardware. The receiver amplifies the incoming signal and then amplifies it to a correlator consisting of a multiplier. When it's multiplied by a stream encoded pulses similar to those transmitted. If the multiplier output exceeds a specific level, it is considered to be detected and recovered. The recognized signal is then demodulated into the original data. Broadband antennas are used for ultra-wideband. Multiband. This form of ultra-wideband divides the lower end and the sign spectrum into three 528 MHz wide channel, extending from 3.168 to 4.952 GHz. There are 128 carriers per band. 100 carry the data, 12 are used as pilot carriers, the remaining ones serve as guard bands. The system permits a wide range and data rates from about 53 to 480 Mbps. Disadvantage and advantage of ultra-wideband communication. First, ability to share the frequency spectrum allows ultra-wideband system to reside below the noise floor of a typical narrow-band receiver and enables ultra-wideband signal to coexist with current radio service with minimal or no interference. However, this all depends on the type of modulation used for data transfer in an ultra-wideband system. Large channel capacity. One of the major advantages of the large bandwidth of ultra-wideband pulses is improve the channel capacity. Channel capacity or data rate is defined as the maximum amount of data that can be transmitted per second over a communication channel. Third is the ability to work with low signal to noise ratios. Therefore, ultra-wideband communication systems are capable of working in a harsh communication channel with a low SNR and still offer a large channel capacity as a result by their large bandwidth. Primary application of ultra-wideband. Ultra-wideband radar is used by fire, emergency, and police personnel to see through walls and doors. Medical versions permit body imaging for diagnosis. Low-cost, short-range, ultra-wideband radars that can be used in cars and trucks for collision avoidance. Automatic braking, improved airbag and deployment, and suspension system are under development.